Hello everyone, my name is Shadib Hussain and the project that I'm working on is can we use a spectrogram that is generated from a heart auscultation to identify any kind of abnormal heart conditions. We would particularly focus on a condition called PDA, which is patent ductus arteriosus. You could see the diagram on the top of my screen where what is a PDA explained very clearly through an illustration. A patient with a PDA condition would have a blood flow going from the aorta to the left pulmonary artery. Under normal condition, it doesn't exist. But a patient with a PDA would have an abnormal blood flow occurring between aorta and left pulmonary artery. Now, my project would try to use the spectrograms generated from a normal patient and a patient with a PDA and see whether the spectrogram can actually can be used to identify that heart condition. So now let me tell you how it's working. The first step is to take an audio file of the heart auscultation. The second step is to perform a short-term Fourier transform on that signal to identify the peak frequencies. The third step is to make it go through a gammaton filter. And the last step is to generate a spectrogram. The process would be repeated for both a normal heart patient and the one. So the program that I used for this project is MATLAB. So let me walk you through the code. So the first step is to load the audio file. Since I'm dealing with the audio file of a PDA patient, I use PDA clipped MP3. I do have the input file. The next step is to perform a Fourier transform on it. So I use the STFT shortened Fourier transform, which is an inbuilt function in MATLAB. I use a Kaiser window with 256 and the beta is 5. The overlap length I kept at 220. The FFT length, which is the L, kept at 256, which is basically for pixelation. The next is to generate the spectrogram. As I said earlier, whenever you're dealing with audio file, make sure you're passing it through a gammaton filter. Gammaton filter is a built-in function already in MATLAB, so I just used it as it is, but I gave the range, which is 0 to fs by 2, the sampling half of the sampling frequencies. The rest of the documentation of reconstructing the signal and trying to see the spectrogram of it is all given in MATLAB. You just have to copy it and you have to change certain parameters to fit your project. So let me just run it. So this is before passing through a gammaton filter. It is now passing through a gammaton filter. And once it has done, now you would see it changed. Yes, this is the reconstructed, as it said, reconstructed signal after passing through a gammaton filter for a PDA file. Now what I did was I changed the file, the source file from PDA to normal to clipped file. So this is for a normal patient with no heart condition. So when I'm running this is before it's passing through a gammaton filter. Passing through a gammaton filter. And this is what's happening as you just saw the transition. Now this is after passing through a gammaton filter for a normal heart with no heart conditions.